So on our quiz on Monday, you should be able to tell me from a picture, is it a pure substance or is it a mixture? And if it is a pure substance, what are the two possibilities if it's pure? Element or compound. And if it is a mixture, what are our two choices for that? Homogeneous or heterogeneous? And you should also know the other names for homogeneous and heterogeneous mixtures. Do you know the names? Homogeneous mixture? Homogeneous mixture is the same as a solution. And a heterogeneous mixture is the same as a mechanical, yes. Is good? And so over the weekend, in order to let you practice for that, there is practice is 3.1E, which is pages, let me just grab those pages for you, 18 and 19. What just happened? Where did it go? Oh, there it is. Okay. Okay. Later on next week, we'll have a quiz on the different types of particles, but not right away, so we'll give you a little break on that. Today, and the other thing that's going to happen next week is we're going to do a lab that uses the Bunsen burners. I wanted to wait until everybody was back. I've still got like 3 or 4 people away on like trips and stuff. So I didn't, it sort of would suck if they didn't get to do the lab because that's kind of the fun bit. But in the meantime, we are going to go on to the next part of this unit, which is section 3.2. And we're going to look at ionic bonding. And that is on page 20. All right, and Tyler's going to tell us some stuff about ionic bonding. First of all, before we talk about ionic bonding, does anyone remember anything we talked about in the last couple days about ionic bonds? Have a chat with your neighbor, see if you remember anything about ionic bonds. Okay, who remembers anything about ionic bonding? Yes, Gavin? It is bonding between ions, yes. Shocking how many people don't remember that. Yes. I don't know. I have grade 11s and they're like, I don't know. What types of ions? It would be the bond between a negative and a positive ion. What do we call the positive ion? That's called a cation. Whoopsie, I did that backwards. I'm so sorry. What do we call the negative ion? We call that an anion. And the positive ion is called a cation. All right, do we know anything else about ionic bonding? Yes. It is not the one where they share electrons. This is the other one.
The one they exchange electrons?
It's the one where one gives electrons and one takes electrons. One gives electrons, one takes electrons. Anyone remember what type of elements? We could have oxygen. What would we have to pair oxygen with, though? Yes? There are nonmetals. Is this the one where we have nonmetals and nonmetals, or is it the other one? It's the other one. What do we pair the nonmetals with? Metals. Okay? So the anion will be a nonmetal, and the cation will be a metal. The one that gives electrons will be the metal. The one that takes electrons will be the nonmetal. Anyone remember the structure that forms? We get a crystal lattice. And remind your partner what a crystal lattice would look like. What would you have? Yeah, like that thing over there. What would we have alternating? Cation and then anion, cation, anion. So plus, minus, plus, minus, minus, plus, minus, plus, plus, minus, plus, minus, and I'm going to say that's big enough because that was tiring to draw even just that, okay? What do we call a single unit? This one might be tricky. We only just barely mentioned it yesterday. A single unit. Yeah. The whole thing is a compound, so this whole thing is an ionic compound. But a single unit of it, one positive ion and one negative ion, makes a thing called a something unit. A formula unit, yes. Okay. Now, none of this will be on your quiz on Monday, okay? The quiz on Monday is just what I told you about before. We're going to take a look at this and we'll be reviewing all of these terms like all over the next few days, okay? Okay, so let's go and look and see what Tyler has to say about all of this.
This video is an introduction to ionic bonds and ionic bonding. Don't know anything about these things, or you feel a little bit rusty? It's no.
We're going to put on the subtitles because this is an old video and the sound quality is not very good. So here we go.
Introduction to ionic bonds and ionic bonding. Don't know anything about these things, or you feel a little bit rusty? It's no big deal, because we're going to start from scratch. So, ionic bonds are one type of chemical bond. Chemical bonds are like glue that holds atoms together. Okay, like here are two atoms that are bonded together, they're connected, they're glued. Now, ionic bonds are the type of chemical bond that hold together metal atoms with non-metal atoms.
Okay, so you guys can fill in on your little table there that ionic bonds, what do they connect? They connect metal and non-metal. Can you guess what metallic bonds connect? Metals. And what do covalent bonds connect? Non-metals. Okay.
Okay, so if you look at a periodic table, there's this big, thick staircase over on this side. And this staircase separates the metals, which are all the elements on this side, from the non-metals, which are most of the elements on this side. So whenever we have a chemical that has a metal connected to a non-metal, that's held together by ionic bonds. So some examples are silver chloride, magnesium iodide, or aluminum oxide. Each one of these chemicals have a metal, this one, or this one from this side of the periodic table, with a non-metal, this one, or this one from this side.
Okay, and we're going to fill in those compound names. So Ag is silver, and do you remember that cations do not change their name, right? So that was it just keeps its name silver, but anions, their ending changes to ide, so that's going to be chloride. Mg, who is Mg? Magnesium. And as an ion, it is still called magnesium, but iodine changes its name to iodide. Okay, so we have that ide ending on the non-metal. And then finally, we have aluminum. Now, do we call this oxygen? Does oxygen sound good? No. What sounds better? Oxide. And one thing that we're going to learn about is that like 99% of negative ions names have 2 syllables. Okay? Negative ion names, 2 syllables. What do I mean when I say 2 syllables? What is a syllable? So if I say hippopotamus, that has 5 syllables. If I say silver, that has 2 syllables. So if you have a nonmetal, this name is oxygen, 3 syllables. When you turn its name into an ide, you only give it 2 syllables, oxide. So you take the first syllable and you add ide. So what about nitrogen? Nitrogen would become nitride. And hopefully you remember some of that because I know you already did some of that in the atoms unit, but that was just a little reminder there, okay? All right, let's go back to Tyler.
So, ionic bonds and all these because there are metals and nonmetals connected together. Okay, so now we're going to talk a little bit more about the how and why that's going on with the bonding here, right? It's like, how do these atoms actually connect together? What's holding them? That's what we're going to talk about next. Okay, so to learn more about ionic bonds, we are going to focus on a chemical called sodium chloride. Sodium chloride is a fancy scientific name for table salt. It's the stuff that you put on your food. So sodium chloride is made of 2 types of atoms. We got sodium. Here's its symbol from the periodic table, and here is a sodium atom right here. And sodium chloride is also made of chlorine or chloride. I'll tell you what the difference between those is in a minute, but you don't have to worry about it right now. And here's a chlorine atom. Now, sodium chloride happens when these 2 atoms come together, when they're glued together by ionic bonds. But the atoms that I have right here, they're not glued together. They're just kicking it over here. They have nothing to do with each other. So I want to talk about what happens to get these separate atoms connected and glued together, like these. How we go from this to this. I'm going to tell you the kicker. I'm going to tell you the end of the story now so you can follow it through as we talk. The reason why these 2 atoms are connected is because they end up getting electrical charges. Okay, this atom is going to end up getting a negative charge, and this atom is going to end up getting a positive charge. What do oppositely charged things like to do? They like to attract. And so because these things get different electrical charges, they are going to be held together by those different charges attracting. Okay, so let's look at the steps that we have to take to go from this to this. The first step is pretty much what I got right here. We're starting with 2 separate atoms that aren't connected. We got the metal atom, the sodium here, and the non-metal atom, the chlorine, over here. Now the first...
What is the charge of the metal atom right now? It's neutral. It's 0. And how about the non-metal atom? It's also neutral. Okay, they both have the same number of electrons as protons.
Thing that happens on the road to an ionic bond is that the sodium atom gives one of its electrons to the chlorine atom. Here's the electron moving between the 2 of them from the sodium to the chlorine. Now this electron moving will change the charges of these 2 atoms. Okay? That's what happens in the next step. Sodium gives away one of its electrons to the chlorine, so it loses 1 electron. It has 1 fewer electron and that's going to give it a positive charge because it lost an electron. But chlorine gained one of the electrons from sodium, so it's going to become negative. It's going to get a negative charge because of that extra electron.
Okay, so we're going to fill in a few boxes and then we'll carry on.
So now,
Whoops, sorry. It's not the button I meant to push. So if you want to add in that NaCl is table salt, you can do that. Okay, so this is table salt. And what does sodium do in this step here? Sodium gives an electron to chlorine. And in that process, both atoms get a charge, and what do they become? They become ions. Okay, and this one is named sodium. Is that? No. What should I be writing under there? It should say lost one electron, right? Lost one electron, whereas this guy gained one electron. And ions have opposite charges, so what do? They attract and bond. I don't know what's in those boxes on the right-hand side. We're going to have to wait for the mystery to be revealed. I have a feeling it's like sodium and chlorine and sodium chloride, but I'm not sure, so let's find out.
these two atoms take on electrical charges. And what do we call atoms that have charges? We call them ions. This one's a positive ion, sodium becomes positive, chlorine becomes negative. Now here's where the difference between chlorine and chloride comes. Chlorine is what we call the chlorine atom when it's neutral. So up here, this non-metal atom chlorine just hanging out here is chlorine, zero charge. But down here, after it's received one of the electrons from sodium, it gets a negative charge. It becomes a negative ion. And now we change its name just a little bit. We call it chloride. So it's the same atom, chlorine and chloride. They're the same atom. It's just chlorine is the version of chlorine with a neutral charge, zero charge. And chloride is the version of chlorine that just has a 1 minus charge. And it got that 1 minus charge because sodium gave one of its electrons to chlorine.
Okay, so let's make sure we filled that in.
Turning it into the...
Whoops, wrong one. So we have this non-metal atom is called chlorine because it has zero charge. But this guy here, this ion, is called chloride, and it has a -1 charge.
Negative chloride. Now people often ask, why does sodium give its electron to chlorine? We'll talk about that in the next video. It's a great question.
Why does sodium give its electron to chloride? Chat with your neighbor about that. Why does sodium give its electron to chloride? Anyone want to take a stab at it? Tristan? Yeah, chlorine wants to gain an electron because it's got 7 valence electrons. Sodium only has 1. So wouldn't it be nice if sodium was like, here, take my electron? Then sodium has emptied out its shell and chlorine has filled its shell. There's a little bit more to it than that, but you can wait till grade 11 to learn that.
But anyway, a transfer of electrons takes place between these atoms, giving this one a positive charge and this one a negative charge. And what do opposite charges like to do? They like to stick together. And so this is what we end up with. The two atoms glued together because their opposite charges are holding them together.
Okay, and that's about it. He goes on and on for a little bit at the end, but it doesn't really say much. Could you guys take a few minutes and do pages 21, 22?
Give me 1 minute. Okay, bro, and then mine. Yeah. Give me 1 minute. There you
Calcium chloride.
I think it's high chloride. No fluorine.
Yeah. Calcium chloride.
Wait, what? I believe. And the
That's what I said.
Yeah, so that'll be obvious. Yeah. So boring. If I get my pencil, and final thing. Your name and back.
It's all the board. Projector.
Oh, I get
She's tired of waiting. Whoa. Touching my bottom. Pouring around. Yeah. Process. What's your constant? No, the numbers have nothing. Really? Yeah. That's weird. That's when it's
Oh, wait.
It's a beautiful song, it's all pitch.
Only at the base, but yeah. That actually. Yeah, would be. Yeah, I love. We have that. But yeah. Oh, yeah, I'm so sorry, Darren.
No one gets that. Audience here.
Yeah. Yeah, one is Laura, it's. Well, it's.
Pretty much, you don't,
Howard.
Okay, friends. I wanted to make sure, and I forgot to do this earlier, that we went over page 17 because I want to make sure you totally understand which one is which for your quiz on Monday. So if we can just take a moment and go to page 17. So the one thing that I want you to notice about this is that, do you see how we have little, this is page 17. Do you see how we have little clumps? Which means it's not evenly mixed. So is that homogeneous or is that heterogeneous? Heterogeneous. What is the other name for that kind of a mixture? Mechanical. Are there any clumps in this one? No clumps. So it is evenly mixed. So is that homogeneous or heterogeneous? Homogeneous. So I'm just going to write homo because that makes it a little easier. What else would we write as the name of that type of mixture? Solution. Okay. Tell your partner, what is F? What is this one here? Heterogeneous or mechanical. Now G. Now is where I see if you're paying attention or not. It's neither. Neither homo nor hetero mixture. And why is it neither a homogeneous mixture nor a heterogeneous mixture? Because it's not a mixture. I threw that one to see if you were paying attention. Okay, so this is a pure substance. H, what do we got here? Hetero. Okay, and how about I? Homo. And J? Homogeneous. What? Which one? You're good? Okay. So are we feeling okay about that?
Yeah.
All right. I also wanted to talk to you about the questions on pages 18 and 19. These ones also ask you, so this is page 18. These ones also ask you if it is a solid. Solids are going to be really organized. Okay, because solids tend to have organized particles. If it is a liquid, the particles will be close together and disorganized. And the other thing about a liquid, how can you tell a liquid from a gas when the picture's kind of lousy? Well, it's a dirty beaker. I'll clean that out anyway. But if you have a liquid, what part of the beaker does it occupy? The bottom. Liquids go to the bottom, whereas gases will, if there was a lid on this, they would completely fill their container. Okay, so a liquid goes to the bottom of the container, whereas the gas, Boba, are you writing this down so that you know what to do? Okay. Whereas the gas fills the container. Your quiz on Monday won't ask you whether things are solids, liquids, or gases, but maybe on the test. Okay? So for part A, you'll be deciding, is it homogeneous mixture, heterogeneous mixture, or pure? You'll decide if you have an element, a compound, or both for part B. And then for part C, you'll decide, is it solid, liquid, or gas? So let's take a look at this first one and do it together. So first of all, is it homogeneous mixture, heterogeneous mixture, or a pure substance? It is heterogeneous. And I'm just going to write het. Okay. Is it an element, a compound, or both? We have, what do we have down here? This one down here is an element. This one up here is a compound. So we have an element plus a compound. And this element, what state is that element? The particles are close together. Are they really organized? No. So this would be a liquid because it all goes to the bottom of the container. So we have liquid. And what do you think about the other one? That's a gas because it fills its container. Gas. So that's how you would do the ones on page 18. Do you guys want some time to work on that? So you won't have much homework for the weekend? Does that sound okay? You're good? Okay. Excellent. And that way also, if you have questions, you can ask about them, right? Yeah.
I never saw your instructions for your themselves, so I see how you're doing. No way. Yeah, so probably because I'll actually do it to yourself. Because it's not like acid. At home with your grandparents, that's the best. Yes. Honestly, family time is just like. Always
I do it.
Yeah. It's kind of so far away, right? So maybe not so much.
Yeah.
Yeah. Yeah. Well, if you look at example, tell me about each particle. How do they compare? They're all black. Every particle is the same as every other particle, so therefore it is a pure substance. That's why we're doing this right now. That's a compound. The liquid. You have two elements. Yeah. Where you're like, I don't like this shirt. Some here. I'm pretty sure it's a solid. Yeah, and it's really organized, like close together.
Go bound, bound. Go bound. Wait, this is worse. I know.
And this witness to,
Yeah. Think about that. Just because of the component.
Okay. Now, if it's compound, all of the particles are the same. Right? So that they can, or is it just like? Bring that in. Okay, no, pure substance, all the particles are the same as, so this is all white, black, white, black, white, black, white, black, white, black. It's not homogeneous mixture, it's not a mixture. Every particle is the same, every particle is the same. Except for pure substance. See, you did it here, so you got. All the particles are the same source. Compounds need to have two or more different elements come together. Found that. Compound, yes. Yeah. 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 It's a compound thing. All compounds. So basically, it's every particle and the other particle. In this case, a particle electrical formula is a negative and a positive. So that's, yeah, and that's that's so that's creating. So for example, this way, well, every yeah. Hi. That's supposed to be the same as those ones. It didn't turn out very well. Yeah. You would get that water, yes. Okay, let's see how we're going here. Yeah, this one? Yeah. Yeah, so this would be like elements, because there's the other, like, this was one else. Yes. I don't know if you want it. Some part of this, that's. Yeah, so it's probably a crystallized. Oh, yeah. How it goes, baby? Oh, that's what they call it. And in fact, thank you guys for the hard work. How long did it take? Monday. Yes. Yes, let me find it for you. Yeah, like that size?
Yeah, that'd be
Perfect.
Thank you so much.
No problem.
Yeah, and what I'm saying is forward.
I'm Dylan. Hello. Okay.
Thank you, Ms. Smith.
You're welcome. See you later. Okay, where do I put your?
Is he?
He doesn't do his own words.
What?
He doesn't do his own words.
Well, that's quite evident from like your test mark.
Come on.
I mean, honestly, I know you're a smart enough guy. You know,
Right, it's
like, so
it was the last day before spring break.
No, it was not.
It was.
Well, that's because of everything else
did
was
it
on
on
Tuesday.
Yes.
So it was not really the last day before spring break. All my grade 9s wrote their test on the last day before spring break.
Let's do the tests.
Yeah, the corrections. You want to do that now?
Yeah.
Okay, perfect. Let me find your test.
Okay, so what we're gonna do, yeah, I'm gonna say here, one of these is here, one of these is here. Okay, and then we can go in between. Okay. Here. Yeah, we'll get rid of those. We've got two. Here, all right. So yeah, so you'll want to do that for 6. Hi, Paul. Yes. Yeah. Yeah, I handed them out yesterday, but I think it was after you had left.
Yeah.
Yeah. Hi, are you here to do corrections?
Yeah.
Okay, good. All right. So you guys are going to grab a couple of chairs. You're going to grab a chair. Sit over here. Do you have a question for me?
I'll tell you later.
You'll tell me later?
But
Okay.
actually,
Yeah.
so Evelyn, she's out for our naturalist, or like karate.
So what was that?
Evelyn.
Evelyn.
Yeah,
Oh.
she's out.
Whoa. Okay.
And then she asked me to like take a daycare for grass and for bars.
Okay, I can do that. Yep. Evelyn. Evelyn.
But then she doesn't want me to do it, so
Okay. Okay. All right, so you need to find your
Thank you, Miss Beth.
Oh, there you are. Okay. All right. So I'm going to sit. Okay. And I will get you a blank version of that test. Okay. So you are going to start with. So okay. Yeah. Yes. Okay, so that's good. Great. Pardon me?
Can I sit here for a second?
Absolutely. Hi, you're here to do corrections? You're gonna pull up a chair over here, so we're gonna go over this a little bit. You're gonna pull up a chair here. You're here to finish your corrections. I got lots of you here today, so maybe a couple of you can sit behind me and I can turn around. Actually, if anyone who's want to sit, do that. So, yes. Soon. There we go. Well, not see. Just for all this.
But yeah, I'd like to come to the day if I can.
Yeah, we just no rapidly, but. Probably like. Thanks. Everyone's so sorry. So as soon as you okay, you're gonna like tap the time, I'm sure will be like sense. I'm gonna check it and see where you're at. Okay? Okay. So now I'm here with all of you. Let's see how you're doing here. So this one here. So you like, what else would you like? Sweet. Yes. Now, all I need to ask, so what I want you to do is I want you to draw me a war model for the human. Let me grab you a 3 out of 2. Well, so it is number 1 true. They do the own little gases, all that little shells. Yes, okay. Is it true that they all have 8 electrons in their valence shell? No. So, yeah. Okay. Regular practice. So you can use 6 and 1. Okay? I'm just gonna do a whole pile of you. How about, yeah? So just put on a chair. So you're gonna start with those 4. And then as soon as you're done one, like, I'll check and we'll see where we're at. Okay, so our first doing there. Okay, how many sick days should we have? Oh, yes. All right, let's check. All right. Okay. Yeah. All right. Now let's take a look at those. Mohammed, did you want to get corrections on your test? Sure. The one that we did before spring break. Oh yeah. Yeah. Why don't you pull up a chair so you're just like right there? Okay. Oh. Okay, and actually, this one, that one, yeah. so what you're gonna do is you're gonna do one of them, and then you're gonna show me, and then see if it's correct. Okay, do you have a template or no? Perfect. Hi. You're here to do test correction. Okay, well, I'm running out of room, so what you're gonna do, that's okay, that's okay. You're gonna sit here, okay? Or you can sit there, but every time you finish a question, yeah, okay? All right, let's see, glass sandwich. Okay. So, actually, let me see here, and you know, who goes far to get to me. Okay. We're going to start with all of number one. Okay, so as soon as you've done one of them, bring it to me, I'll check it, see if it's correct, and if it's not, we'll throw one. Okay. I have no idea if that's working. That's a bonus anyway, so we're not gonna worry about it. Okay. Yeah. See. Okay. Oh. Let's take a look and see what we've got to, okay? We've done front right? Well, there. Okay, so. Good. This one. Right. Pretty good. And then forming a positive line. You might get some wrong to this one. No, okay, then I'll let you. Oh, you did this one, okay. So if you gain or lose protons, that actually changes the elements. So that's gonna be a problem, like if you had 8 protons and you had 7, you go from being opposite to being negative. Yes, 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 yes. How you doing? Let's take a look here. So. Your safety is correct. Are we happy with the way we're breaking that out? Yeah, for sure. No, why not? That's right. That's right. Now, I'm going to tell you that for multiplication, the best way to do it, because you've got your colors, right? Okay, so what we're going to do, okay, perfect. All right, so what we're going to do now is we're going to take 1.2. 5. I'll go on. Well, yeah. Okay, so the easiest way to do it is to just put in the does that make sense? Okay. And this one. Okay. How many things should this have? One. so that you don't hear. So, hold on, talks about the happy trust. That's gonna be a huge difference for you. It's shocking how that works, right? I know. Okay. So now we have, this is the front, just this one. So if I told you you're in your kitchen and you need to make me a saturated solution of salt water, what would you do? Sorry. Okay. All right. So you can get out of here. I'll get your mark to you on the right. Okay. Hi. Okay. Let's take a look at these. So how many syncopates in each of these groups? So there's 3 here. How many here? 2, 3, and 4. So how many should we have in our answer? 2. How many do we have? 1 down. Okay. This. Okay. See this here. Oh, yeah. Sorry, I was doing the pencil. How do you know this? Let's take a look. Okay, so we have. This is called an intermolecular force. Okay. Inter means between. So if you go on an international flight, you're traveling between nations. So it's between molecules. And the key thing here is that the large particles do that we get caught in. So let's say that we had, this is our solution. This is our system. Here comes some light. What does light do when it gets to see? Bounce. So the solutions are clear. Okay. What happens in a suspension of this one's body? Yeah, it bounces off. What's it bouncing off of? This like bounces, that bounces off something. What is it bouncing off of? Yeah, exactly. And then these ones, they're so small, yet that they can bounce. Does that make sense? Yeah, I get it. I get it. Yes. Good. Okay. Good. Okay. This. Hi. What can I do for you? Oh, yeah. Oh, and we've got to redo. Okay. You know what? Can I hold on to this so I can re-record it for you? Yeah. Thank you very much. Anything else? Yeah. Okay, so I'm going to look that up. I think may just be also significant calculation. Thank you very much. Okay, I'll take care of that for you. Okay, so here we have This one, you need to take these and put them both in the same power of 10. Okay, so like, let's say we had 1.62 times 2. Have to do 2 or what would that be? We made it times 10 to times 2. Okay, this, you call the major donuts. That's it. Nope, they're just called the major donuts. All of these together, major donuts, that's their name. Nope, those sections together, major donuts. So those two sections combined, that's what they're called. All right, so I'm checking this one. Okay, this one is that. This one. Now, do you have work for this one? I did. Okay, yeah. -3. And then we have subtracting 8.914. Times 10 to the -3. Now, what did you do with the other? Did you include these? Because they're times 10 to the 3. No. So, no. The point of putting them both in the same power of 10 is that you will then ignore this part, you will factor this out. Okay, so you'll have 16.2 minus 8.914 times 10 to the -3. Okay. So you're going to do this because otherwise your calculator will move the decimal back to where it was before, and you won't be able to tell where your answer is. Yeah? Okay. Yeah, so what happens is if you go from this spot bigger, right, because that's a negative, so this has to get smaller. If this gets bigger, smaller. Yes, so we have 4.8. So now we have this number and this number. And just like I was telling Sam, that we're now going to factor out the 10 to the 2. So what we're going to have is bring it up 1.62 plus 0.894. We factored out the times 2. So what you're going to do is you're now going to add those. Or is that subtraction? Sorry about that. You're going to subtract those. You're going to write down what you get. And then times it. Oh. Okay. So let's check this. Okay, so physical means there's no reaction. And no substances. Yes. Okay. Good. All right. And then this one, condensation. Yeah, that's correct. Oh, we check this. Yes. Here, that's correct. That's correct. Very nice. Okay. All right. Okay. So this one was good. Let's see. An ion is a particle that is a positive relative charge. And we'll do that this unit too, so it's handy. Okay. All right, that's good. Good. We got it back in date. Yeah. Oh, yeah. Yeah, awesome. Thank you. Well, I'll get your updates from you later, okay? You know what? I have no idea where your other test is, so what I'm gonna do is, if you do well on your other tests, what I will do is I will fill that one out eventually. Does that make sense to you? No, okay. If you want to come back after school, we can actually, I'll pull a blank form of it, and we can just go through it together. Okay, cool. All right, we're going to get this. So we have, this is good. Now, if you look at this here, where is your uncertainty? Yeah. Where is your uncertainty? Yeah. So where would you round this off to? Where? At 9, so that's your third digit. So your second digit after the decimal is uncertain. Yeah.
Yeah.
Okay. And so what you're going to do now is you're going to you're about to the top. What are you guys doing? Okay. Just good work for that. Okay. This one, what's the rule for adding and subtracting? Yeah, so this uncertain in this number. Oh. Base 4 and 5 are uncertain. So, what's our first uncertainty again? Because that's not uncertain. That's not uncertain. That's not your first uncertainty. Or, okay. So we have, okay. So for that first one, you know what, we can come up here now. Because I got more chairs now. And you're gonna show me what you did on your stuff. Yes, okay, so when we add subtract, what's the rule? Yes. Okay, so there's your uncertain digit, and there is your uncertain digit. Yeah. So you want to write out your whole answer and then go to the first uncertain digit. So do the calculation again. All right, write out everything and then underline your uncertain digit and then round up to that. Okay. No. Okay. So you have 16.2 minus, what do you get when you do this? Like, what's the literal number you get when you do this? Minus 8.9. Okay, oh. What do you want? 16.2. Oh yeah, that was correct. I'm so sorry. My brain is down. So yeah, so we have 7.286 here, right? Yeah, 7.286. Yeah, we use subtraction, what's the rule? It's the same thing with that. Yes. Yes. Okay. Yeah. Okay, yeah, so that's what we get, right? Or, yeah. Yeah, so we're very close. You want to put it signing out from which, so I got more space. Sit on the side, some of you can, because it's going to carry around and then, you know, worry about being not facing, you can be like, here I am, right here, right here. Okay, so, um, and we don't get that one without the sun or anything. Do you know how to go from prefixing it to a prefixing it? Okay, so what you're gonna do is anytime you have a prefix, first thing you do is you convert it into a plain prefix. Okay. And then you will convert it into other prefix. So this is going to be a two-step process where you're going to start by going from anagrams to grams and grams to centigrams. Okay? All right, let's check this. Down on this one. This one is 4. Okay, when you're multiplying and dividing, forget everything I said about changing to the same power of 10, just throw it in the calculator. Multiplying and dividing is your friend, it's like, throw it in the calculator. Okay, all right, let's check and see this. All right. Okay, so let's take a look at these and find out why. Okay, so here, this is multiplying. What is the rule of multiplying? And we grab 2 how many this, but we don't have this. Yeah, so that has how many? 5, and how many does this have? Oh, really? 4. So how many should we have here? 4. Let's round to the smaller number of C6. So 1, 2, 3, 4. What would that round to? Yes. Okay. So this one here. Yes. Okay, that's good. So now what you're going to do is subtract. So what is the rule for subtraction? The first answer, let's see what that answer here. So how many decimal places along is this? 1. 4. Yeah. Okay, cool. This one, what do you need to get that number? It's 6. Oh, okay. You know what? Honestly, I like just throw everything in the calculator. Okay, so try that again. Okay. All right. I'll get in there.
like this.
What's that times that? 8 times. Equals, it's not 194, it's 1.61. Okay, let's just call it 6.1. But we'll keep an underline there because we know that that is the uncertain digit. Yeah. But now when we do that subtraction, now we can, so let's see, now we subtract 2.48. Yes. So the moral of that story is don't round off too early. Just keep track of where that safe is. Okay. All right. So this one is better. Now this one, different rule for adding and subtracting. Okay. So when it's multiplying and dividing, we go to the least safe basis, smallest number of safe basis. When we're adding and subtracting, we go to the first uncertain digit. Okay, so who is the uncertain digit in 21? Just ignore that number. What's the uncertain digit in that? So anyone want to write out the smoke? Let's get it. This is good. Yes. Okay. Grab the tool. I'm like,
Yeah.
so I need to be able to interact with you, right? Yes, 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 okay. Yeah. Okay. And because you guys have been here today, if you need to come in on Monday, you can also come in on Monday. Yes. All right. So, and this one around. Plug everything and see what we get. And remember, this one is multiplying and dividing. So you can just throw it all in with this times that, times that. Divide by the number of one, divide by the second number of one. Okay. Okay, so this is okay. So 1.2. And to the 5.
Hey, there's another one right there. You gotta go. You gotta go.
Yeah. Okay. Also like average, so now it's negative. Yes, yeah, okay. So if you want to my try to down. Okay.
I will respond to that.
Yes. Yes. Yes, that's. Yeah.
This is
Really? Are you allergic?
to not slang. Every single one.
Like, don't worry about it.
I'm gonna go away here. Do you like die? Yeah.
Oh, flour.
Yeah, that's what I was thinking. It's like, it's the first thing I saw. Yeah, that's what I was thinking.
You cannot pull out the RCMP off of the Spanish.
I'm gonna put them on my thumb. Oh, well, they would literally arrest you. Your Ziploc bag.
You haven't run the I was like wrong. How many more? He made eye contact. They didn't realize I was staring at him.
Hi. How are we today? Good. When does class start? It started already, hasn't it? 39. Okay, excellent. All right. All right, we're going to learn some stuff today from Unit 3. So if you could get out your yellow book. And if there's anyone who does not have a yellow book, let me know. Okay, I've got extras. Anybody need a yellow book? Ethan, put your phone away, get out your yellow book. Andrew's what? Okay, thank you for listening. I will find out for you.
I know 8, 3, and 9 and 9.
Okay, yeah, I'll find out for you. Okay.
Miss
Yep.
Spence, I spotted on the stage.
Yes,
Added 3 more sick of images.
it's actually not quite there yet. No, not quite. Okay, so we'll take a look at that later. Hold on to that for you.
Alright, yeah, sure.
All right?
Sounds good, yeah.
I have a quiz 9 and 10.
Yeah, just hold on. We're gonna do this first.
Oh, yeah,
okay?
sure.
Yeah. Okay, let's find Chem 11. Atoms. Whoops, I guess I can press